Hello, good afternoon to all of you. I hope my audio is clear and my video is also visible. Sorry for inconvenience. So in last class, we just discussed about how to find out the time period for the spring mass system. And we derive a expression if our spring that is placed in the horizontal manner, then what is the time period? Beta, we already see that if the spring is placed in a horizontal position and mass of spring is m, mass of block is m, spring constant is k. So in this case, our time period is nothing but t equal to 2 pi root over m upon k. On the base of similar concept, I have given a homework problem for you. When spring is connected in vertical position through a mass, then what is the time period? And beta, in this case, if spring is connected in vertical position, let's see. Suppose if spring is connected in this manner, block of mass m and spring constant is k. So what is the first step, beta? What is the first step? First step is we have to find out equilibrium or mean position. So anybody in this class, can you tell me how we can find out the equilibrium or mean position? How we can find out equilibrium or mean position? Please tell me, come on. How we can find out? Anybody? What is the procedure, beta? First of all, we have to see where the net force is acting. We know that beta, in initial condition, the spring is placed in vertical situation. It means due to weight mg, spring is elongated. Why spring is elongated? Because of the mg force acting in downward direction. So we can see that initially spring is not in its natural position, although it has possessed some elongation. So we can say that, sir, what will happen because of the orientation, the spring will possess some deformation, and as we connect the mass, as we just connect the mass, spring will start elongated. Okay, so we can say that suppose if we do not connect any block, then the position of natural position of spring is this. After connection of the mass, we can say that spring possesses some elongation and say that this elongation is nothing but x naught. This elongation is nothing but x naught. I hope this is clear. So what is the spring force, beta? We can say that this is nothing but kx naught. What is the mg force? That is mg. And it is the situation when mg is balanced kx naught. So we can say that this is our equilibrium position. And equilibrium position at kx naught equal to mg. I hope this is clear to everyone. What is the next step? Once you got the equilibrium position, what we have to do next? Next, we have to slightly displace the block. So if we slightly displace the block, suppose this is our main position, and from main position, if we displace our block as a distance x, say this distance is x. So how we can write down, beta? We can say, sir, this is supposed that main position, and from main position, if the elongation is block, that we can say x. So what is new net force at new position? We can say this is our natural position, and this elongation is nothing but x naught. And further we slightly displace our block from main position, that is x amount. Then what is the spring force in this case? In this case, spring force will become k x naught plus x. I hope this is clear. And the gravity force continuously acting, which is constant in nature, that is in downward direction. So can anybody can tell me what is the net force in this case? We can say, sir, what we see here, if we slightly displace the block in downward direction, and if we see that just remove our external impulse, then block will have a tendency to regain its original position. It must move towards its main position. So what is the net force beta? That we can say mg minus spring force. So this will equal to k x naught plus x. So if we solve this, what we will get? mg minus kx naught minus kx. At mean position, we already know mean position relation. Sir, at mean position, kx not equal to mg. So what we will get here, beta? If we put the value kx not equal to mg here, so this will equal to minus kx. And again, we will get our familiar equation. And this equation tells about the whole motion is nothing but SHM, because net restoring force is directly proportional to x, and sign that signify that restoring force rate acting opposite to displacement of the particle. So once we will get this value, we can directly say that the time period in this case is nothing but t equal to 2 pi root over m upon k. So what is the learning of this question? Either we discussed in previous case when spring is placed in horizontal direction, either spring is in vertical direction, the time period will remain same. Why this is happening? Why this is happening? Anybody can tell me why this is happening, beta? In first case, we can say that in this case also the time period is t equal to 2 pi root over m upon k. In this case, say this is the case 2, the same time period is again come. What is the reason behind this? Because we can say that in both the cases, the force is acting that is constant in nature. And we can say that the force that is balanced by the spring force. Again, if we discuss about the third case, when the spring mass system is placed in the inclined plane, the same result will come, beta. How the same result will come? We can say that if our angle of inclination is theta, then we can say that there are two components of force mg, and we can say that from Newton's law of motion, the one force that is acting along the incline, that is mg sin theta. Another force that is acting here, say mg cos theta. And we can say mg cos theta is nothing but that balance the normal force. Okay. So mg sin theta, that is constant in nature, and that will create a elongation in spring. And spring elongation that must balance mg sin theta. So we can say that this mg sin theta is acting like as a constant force here, like that F like as mg. So the same result is also come in this case, and the time period is nothing but t pi root over m upon k. So this is very important result, beta. Irrespective of either we can say that our spring is placed in horizontal direction, either spring is placed our vertical direction, either spring is placed in inclined plane, the value of time period will remain same, the value of angular frequency remains same. The next case we have to know that we must have to understand the concept when two springs connected in parallel. What will happen, beta? This is very important result. We can see that suppose this is the first spring and say this is the second spring. And we can say that in this case, both the spring having spring constant K1 and K2 connected in parallel. It is just similar to resistance. If we can see that the first end of this spring is connected to this fixed point, at the same point the first end of second spring is connected, and the second end of the final end of the both the spring is connected at the same place. So this is the way that we can recognize that springs are connected in parallel. And what is condition, beta? Whenever spring is connected in parallel, and suppose we apply a force F, then what will going to be happen? Because the spring is connected in parallel, then the both the spring have suffer same deformation. Suppose if we apply some force F here, then what will happen with the both the spring? Suppose that our first spring possesses some deformation. Say that this deformation is the delta. So the second spring is also possess the same deformation because of the constraint that is connected at the same point. So what is the very important characteristics, beta? When spring is connected in parallel, when spring is connected in parallel connection, then what will happen? In parallel connection, deformation in both the spring will same. So we can say deformation, I mean to say elongation or compression. Deformation is equal to same in both the spring, and the total force that is distributed into spring. Say in this spring the force is F1 and this spring force is F2. So the net force F is equal to F1 plus F2, and deformation we can say delta X remains same. This is the very important. And by using this equation, if we replace a single spring which are doing the same work, that is acting by these two springs, this is known as the equivalent of the spring. So we can say if spring having spring constant K1 and K2 having performed some work, some type of task, the same type of task is performed by this equivalent of spring. Say this is the K equivalent and mass is M. And the K equivalent in the parallel connection is nothing but K1 plus K2. We have to remember this formula. This formula is on our tip. I hope this is clear to everyone. JNV Kolhapur, JNV Bhavnagar, I hope this is clear. All the JNV who have joined in this session, so I would like to request all the concepts should be crystal clear, whatever I delivered here. Okay, beta. In the next, that is the second connection. Now I am going to discuss that is the series combination. Yes, Yano beta, series combination. So what will happen, beta, series? Sir, it is similar to wire. In the resistance, when two wire is connected in the series, then we can say that the same current that is possessed between the all the wires, not two wires. Suppose n number of wires are connected in series, so we can say the same current is passing through all the wire. Yes, Yano beta. Yes, Yano beta. Okay, sir. So sir, beta, JEE main, Jan attempt 2023 and JEE main April attempt that is going on in the last and present week, the same type of concept that is asked in the parallel combination. Okay, so what is the concept that we have to understand here? Suppose this is the spring and this is first spring, and suppose that the last end of first spring is connected with first end of second spring. So such type of connection is known as the beta parallel connection. Series connection. Say this is the K1 and this is the K2 having spring constant of the two spring. So how we can proceed, beta? How we can understand? Sir, as we can say that key in the register, when we are talking about the register R1 and resistance R2, and suppose the current I is passing through R1, the same current is passing through the second resistance. In the same manner, if we apply a force F here, the same force F which is passing through the second spring, the same force is transmitted to the first spring. So this is the basic concept. In series combination of spring, force will remain same. The force transmission will remain same. That is the concept. So force will remain same in all the spring which are connected in series, will remain same. I hope this is clear. Okay, sir. There are two types of parameters which we need to understand. One is the displacement and another is the force. In parallel connection, deformation or displacement is same. Then force is divided. So it means in series connection, if force will remain same, if force will remain constant, then which parameter will go divide? So there is only one option, that is the deformation. So we can say in this case, say deformation in the second spring is x2, then the deformation in the first spring is x1. If we want to perform the same task which are doing by the spring 1 and spring 2 combinedly, the same task is performed by the single spring, and the single spring is nothing but known as the equivalent spring, and the spring constant of this spring is known as K equivalent. I hope this is clear. Yes or no, beta ji? We can say that in this case our Ax equivalent is nothing but Ax1 plus Ax2, and K equivalent is write down in the same manner, that is we can say that we can write in the case of resistance but in parallel, that 1 upon K1 plus 1 upon K2. What is the bloody point we have to understand here, beta? Resistance come into picture for the loss of energy, for the loss of electrical energy below. Because of the resistance, there are some dissipation of heat occur in the circuit. Are you agree with me? But what is the role of spring? Spring does just opposite task of the resistance. Spring come into picture to store some mechanical energy. Spring come into picture to store some mechanical energy. It means the series combination of resistance will convert here parallel combination of the spring, because both having opposite nature. I hope this is clear. By using this concept, you can recall this concept. In the exam pressure, if you don't able to recall the concept, you can think spring perform opposite work of resistance. So we can memorize, because we already know in 10th standard what is the role of the resistance and how two resistance are connected in series or parallel. I hope this is crystal clear, beta. Yes, Anu. If this is crystal clear, then we move for the next. We do some problem on some problem on, beta, how we can find out the time period. See, beta, the first problem, tell me answer, beta. I hope you guys can tell me correct answer. This is the spring constant K, and this is again spring constant K. A block M is connected in such a way. We have to find out what is the time period of SHM. Actually, we slightly displace this block M from its equilibrium position. If we slightly displace this, then is this block is perform SHM. It is already said in the problem कि block is performed simple harmonic motion. For the small displacement, slightly displacement of the block, then we have to find out what is the time period. Anybody in this class, tell me answer in the comment box. Tell me answer in the comment box. Come on. Tell me answer in the comment box. First of all, if more than one spring come into picture, then we have to think each spring is connected in series or springs are connected in parallel. How we can think, beta? How we can think? Suppose we slightly displace this block. Listen here. If we slightly displace this block in rightward direction, say the deformation that we given to the block in rightward direction is x. So we can say this spring is compressed by x amount, and the first spring, say this is the first and this is the second, and the first spring will elongated by the x amount. Are you agree with me? The same amount of deformation that will occur in both the spring. And once we recognize the deformation is same, it means the combination is nothing but parallel. I hope this is clear. Yes or no? How we can recognize? Slightly displace the block in rightward direction. The same deformation that is occur in the second spring is equivalent to the same deformation that is occur in the first spring. So we can say this is nothing but this is the parallel combination. If this is the parallel combination, then what is the K equivalent, beta? That K1 plus K2. So what is the K equivalent, beta? That is K plus K, that is the 2K. Then how we can write down the time period? We can replace this diagram. Sir, one another way to think this problem. There are two fixed points, and if we join two fixed points at a single point, suppose if we want to join this point at this point, so this will something like this. This system will something like this. Just try to visualize the concept. If we join two fixed points at a given point, so this system will like this. Take this fixed point and move at this fixed point, because fixed point is fixed point that have same location. So this is very much clear that is a parallel combination. Then what is the result, beta? That is 2 pi root over m upon k equivalent. So what we will get here, that 2 pi m upon 2k. I hope this is clear. Okay. So let's move. Suppose if the sometimes of this type of questions is already come into picture, and I hope you guys can solve such type of questions easily. See here, beta. This is the first spring. This is the second spring. Again, say this is the block M. All the spring having the spring constant K. In this problem, it is asked about what is the K equivalent. First problem, what is the K equivalent, and second problem, what is the time period. I hope this is clear to everyone. Yes, yeah, no, beta. How we can solve it? How we can solve? Can you tell me answer? These two springs are in parallel. These two are parallel. This system will write. This will become 2K. This will again become 2K. Yes, yeah, no, beta. Yeah, and this 2K and this 2K again in parallel. K equivalent is nothing but 4K. And time period we can write down 2 pi root over m upon K equivalent, that is the 4K. I hope this is clear to everyone. Let's move further. Next concept, beta. What is the concept of the angular SHM? As we discuss about the linear SHM, in linear SHM, our net restoring force is proportional to minus times of Kx. So here we just want to replace the linear variable with the help of angular variable. How we can replace, beta? We just want to recall the concept that you already studied in your 11th. Sir, in linear variable that the displacement is x, then angular variable the displacement theta. Okay, sir. In the linear variable, the task is performed by the mass. In angular variable, the same task is performed by the moment of inertia I. Am I correct, beta? GNB Bhavnagar, am I correct? Yes or no? The same task that is in linear variable, say this is the linear and this is the angular. Okay. By analogy, that things will become very easy to understand. We can say the same task is performed by omega, that is angular velocity. Sir, listen. Here we can say the one term that we can say acceleration. Here the same term is represented by angular acceleration. Here the same task that is performed by the force that is equivalent to torque. I hope this is clear to everyone. Okay, beta. So what is happen, beta? It is just, if we want to take a simple example of the simple pendulum, and we know that the simple pendulum is nothing a big deal, beta. It is a thread which is connected with a bob. Bob, that is nothing but a condensed mass, we can say that concentrated mass. And if we slightly displace this bob in either direction, and what we can see here, this bob will perform to and fro motion about this mean position. And because we know that the bob is not moving in straight line, it moves about a point, because such type of motion is to and fro, and the amplitude is small, and the force that comes is proportional to single power of x. Here the role of force is performed by the torque, and torque is proportional to single power of theta. So that means it can say that angular SHM. Here we can say that it is a disk, and if we rotate the disk want to achieve its original or mean position. By this we can see here, this is the mean position, and if we rotate the disk here, the disk will perform something like to and fro motion. Such type of motion is known as beta angular motion. I hope this is clear. By using this analogy, how we can write down the force? We can say, sir, in place of force, we can put the torque. In the force of K, that is the SHM constant. Here, K is also SHM constant. There is no problem with K. Okay, sir. And X is replaced by theta. I hope this is clear to everyone. Yes, yeah, no, guys. Come on, yaar, guys. Give me a thumbs up if everything is clear. Sir, listen. Sir, as force equal to M into A, can we write down the torque? Why not, beta? Torque is always written as I into alpha, because mass is replaced by the I and acceleration is replaced by the alpha. Okay, sir. So this will equal to K theta. Yes. Sir, so what is the value of alpha here? That minus K upon I into theta. Sir, listen. Here A equal to minus K by M into X, and K by M is nothing but that is known as omega square. That is known as omega square. Yes or no, beta? Yes or no? Oh my God. In place of a alpha, in place of X theta. So this K by I performing the same task which is performing in the linear SHM by omega square. It means it is nothing but omega square here. Yes, yeah, no, come on, guys. This is omega square. Once we will get omega square equal to K by I, we can say omega equal to root K by I. Sir, listen. Omega is nothing but 2 pi upon t. If somebody asks to time period, by which minimum time the bob will attain its original position, then what is our answer? We can say, nikal le. As we know the value of omega, we can put 2 pi upon t. कोई बात है क्या? Yes or no? What is the value of time period, beta? What is the value of time period? Sir, time period will equal to 2 pi root over I upon K. Oh my God. The result will just replace the mass by the moment of inertia. I hope everything is clear, beta. One thing we have to keep in mind, whenever moment of inertia come into picture, we have to calculate the moment of inertia about some axis. I hope you already studied in rotational motion. So here, if this bob is connected, so by which axis, by which point the bob is rotating? So we can say that this is the axis passing through this point. So we have to take the moment of inertia of this bob about this point. And everybody know, not even me, even every Rinku, Tinku, Sintu, everybody know what is the moment of inertia. That is nothing but mass into distance of mass from the axis square, that mr square. Am I correct, beta? Am I correct, beta? JNV Yanam, JNV Kolhapur. Is it correct, beta? What is the moment of inertia? Mass into distance of mass from the axis about which we want to calculate moment of inertia. And listen one thing, always take perpendicular distance. That is the concept. Over khatam hai, beta. Yes, Yanu. I hope this feel very easy to you, beta, and you can understand this concept very easily, beta. So let's move. Let's see the some application part. One is the simple application part, beta. That is simple pendulum. Yes, Yanu. Oh, sir, simple pendulum. Why this is simple? Because from class 9th standard, we just listen about the simple pendulum, because that task is very simple. Why task is very simple? If we consider a thread and if we connect a bob, a mass with this thread, so this is known as this type of combination is the simple pendulum. And say this is the point of suspension. About this, the bob which perform angular motion like this, beta. So this is the stream position where bob can reach. So this is known as the right stream position. This is the left stream position, and bob will perform angular motion something like this. So which one is the mean position, beta? That is the where the net force will become 0. So this is the mean position. Here mg is balanced by the tension that in thread. But in this position, if you want to say what will happen, beta, how this verb will come at mean position? What is the force that is responsible to bring this verb in mean position? Can anybody can tell me, beta, how we can say? See here, sir. If we say this angle is theta, and for some time say this angle is theta, why not? We know that mg is acting in downward direction, and by vertically opposite angle, this angle will become theta. So what is the component of mg in this direction, beta? That mg cos theta, and one component that is acting in this direction, mg sin theta. Again, we can see that beta mg cos theta is must balanced by the tension in thread. So this is balanced by the tension. What about mg sin theta? Who will balance mg sin theta? Can anybody tell me which force come into picture to balance mg sin theta? So what is your answer? Your answer is, sir, there is no force that come into picture to balance mg sin theta because there is no force present. So we can say that this mg sin theta is responsible to bring this verb at this position. So this mg sin theta is acting like as a restoring force. This mg sin theta is acting like as a restoring force. And this restoring force that we can see that because of this restoring force, verb will retain its mean position and come into its mean position. The same thing happened for this position also, theta, theta, theta. This will become mg cos theta, this will become mg sin theta. I hope this is clear. And at mean position, we can say mg must be balanced by tension. So at mean position, the equilibrium position, that net force is 0. Is it clear, beta? Yes or no? Sir, how torque into come into picture? Torque is nothing but beta force into perpendicular distance. So we can say that if suppose that if this point is O, and if you want to find out torque about the mg force about point O, how we can write down the torque? Because we can say that sir, the net torque is equal to I into alpha, and here we interested in angular motion, that's why we want to calculate torque. So we can say, sir, there are two forces, one is mg and another is tension. Unfortunately, tension is passing through the point of suspension, and we calculate the torque about point O, that is point of suspension. Because the force is passing through point of suspension, so we can say the distance of force from the point of suspension will become 0. That's why the force due to tension is the torque due to tension about the point of suspension will become 0. I hope this is clear. What about mg cos theta, beta? mg cos theta is also the line of action of mg cos theta is also passing through point O. So the torque of mg cos theta is again equal to 0. So which force is creating torque here? JNV Bhavnagar, JNV Kolhapur, can you explain me which force is creating torque? And that torque is known as the restoring torque. You can message in comment box JNV Dahod, any JNV. If you know the answer, you can in comment box which force creating torque here, because unfortunately tension, torque due to tension is 0, torque due to mg cos theta is 0. So the only component is remaining mg sin theta. And see here, beta, see here, sir. If we draw this diagram here, see here, beta, sir, this is mg sin theta. Yes. This is length of string. Yes. So this force is very good, beta. This force is perpendicular to length. Yes. What is the torque? Force into perpendicular distance from that point about which we want to calculate the torque. Okay. So we can say this will equal to mg sin theta. This is the force. And what is the perpendicular distance? That is L. Okay, sir. I into alpha. Okay, sir. Sir, one thing I want to say again. The displacement, the disturbance given to verb is very, very small. That is not too much large. So we have to always remember whenever we want to check the SHM, In the case of linear displacement, x is very, very small. In the case of angular displacement, the theta is very, very small. So here theta is very small. We have to, and generally this is from 0 to 6 degree. We have to keep in mind that theta is vary between 0 to 6 degree. Okay, beta? So we can say, sir, this will equal to mg sine theta into L. Sir, what is the I? I is the moment of inertia. About which point? About point of suspension. So this is the mass. What is the distance of mass from this point? That is the length of string L. So this will equal to ml square into alpha. See here, m and m cancel out. L and L cancel out. What is the value of alpha, beta? What is the value of alpha? We can say that this value of alpha is G upon L sine theta. Sir, theta is very, very small. Whenever theta is very, very small, beta, we can write down sine theta equal to theta. If anybody asks me why sine theta is written as form of theta when theta is very, very small? Anybody in chat box, can you give me answer? Whenever theta is small, why I am going to choose n theta equal to sine theta? Anybody in this class? It's time to create your influence. I want to discuss about why I just take theta that is equal to sine theta. See here, beta, if you don't know, see here, that is a beautiful concept. Because we know that if we draw the graph of sine theta, this is just similar to like this. I hope this is clear. So this is, if we want to find out the value of theta just near about origin, so this value is something see like straight line. Agree? If we want to draw the graph of y equal to x line, so this is like this. So in the neighborhood of 0, the line is something like y equal to sine theta or y equal to sine x, and y equal to x is just similar on the neighborhood of 0. See this part. Come on guys, see this part. See this part very carefully. This part and this part almost similar part that when x is tending to 0. That's why we can see that when x is tending to 0, then the behavior of y equal to x line and y equal to sine theta or y equal to sine x is almost same. That's why we can say that if sine theta is equal to theta. That is the typical concept. And we can surely say that 90% students do not aware about this concept. Okay. So we can say alpha equal to G by L is equal to theta. Sir, one thing I want to discuss. What, beta? The thing is that if we displace this bob from mean position in this sense, say this is the anti-clockwise sense, then the restoring force is acting in the clockwise sense. Yes, that must happen because this is the condition of the restoring force SHM. If we displace block in positive x, then restoring force into negative x. In the similar manner, if we give the angular deformation to bob in anti-clockwise sense, then the restoring force come into clockwise sense. That's why we can say that if you want to say that this here if you want to put minus sign, there is no problem. We can take. Why we can take minus sign here, beta? Because we know that we displace the block in anti-clockwise, but the restoring force, the torque of restoring force is acting clockwise sense. So that is the for your understanding purpose. If you already assume that this torque is the restoring, so there is no role to put negative sign here. Okay, because you already know if somebody asks to me where is negative sign, then you can say that what is the physical meaning of negative sign. If we compare this result, our standard result, that alpha equal to omega square theta, so we can say omega square is nothing but root over G by L, and we can say that, sir, this is the value of omega, root over G by L. Omega is the 2 pi upon t, so this will equal to G by L. So what is the value of time period, beta? The time period will equal to 2 pi root over L by G. And very influencing result. Why this result is important, beta? GNV, all the GNV see this result. Why this result is important? Because if this result mass is not come into picture, it means the time period is independent of the mass of the bob. And this is proportional to root over length. At the length of string is increased, then time period is increased. And time period is also depend upon the value of G. And we already know from our gravitation chapter, at place to place, as we move in upward direction, as height, as we move at depth of the earth surface, as we move far pole to equator, then the value of G is already vary. So we can say that the time period of the simple pendulum can be vary by varying two factors. One is the length and another is the gravitational acceleration. I hope this is clear to everyone. Yes, yeah, no, beta. If everything is clear in this class, so give me a thumbs up, because now I am going to close the class, and the tomorrow class is very important for you guys, because in the last class we summarize all the concept along with PYQ of the JEE and NET, and we also cover the superposition principle. Okay, so if everything is understandable from the today class, then give me a thumbs up. And now time to take the close the class, beta. Please give me a thumbs up if everything is clear. Come on. Yep. Am I audible? Come on, guys, because your thumbs up is acting like as oxygen for me. So why you guys? Please come on. Okay, beta. Okay. So what is your homework for today, beta? I am giving a homework problem for you. And what is homework problem? This is known as the physical pendulum or compound pendulum. And you have to find out, beta, you have to find out the time period of this compound pendulum. What is the compound pendulum? I want to give one hint from you guys. Anybody which is hinge except its center of mass, any type of shape, any type of object which is not hinge at its center of mass, it can be hinged apart from this point, except from this point. Such type of system is known as the compound or physical pendulum. Sir, अगर मैं इस बोतल को इस पॉइंट पे हिंज कर दूं तो ये फिजिकल पेंडुलम हो गया? हो गया, हो गया. Sir, this is the physical pendulum. Yeah, my hand is acting like physical pendulum. देखो बेटा, इस पॉइंट पे मैंने हिंज कर दिया. This is the physical pendulum. क्या फिजिकल पेंडुलम की बात समझ में आई? This is the physical pendulum. Yes, yeah. What is the physical pendulum? Any object which can be hinged except its center of mass. If the object is perform simple harmonic motion after giving small angular displacement, the such type of combination is known as the physical or compound pendulum. So our next task is find out the time period of the physical pendulum. Okay, beta. In the same concept I already discussed in the simple pendulum. You want to try how we can derive the time period, and that is also a beautiful formula. So this is important for us. Okay, beta. So thank you so much for attending the class. We will meet in the tomorrow class along with a lot of numericals and few new concepts. So thank you so much.